Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, I'm going to be talking about GlusterFS again. This time we're going to do a lab. I'll show you how we set it up and some of the things you can do with it. Stay tuned right after. I have two servers here, so this is going to be my client over here on Blue Ice, and this is going to be one of my servers over on the Gluster service side. So what do we need to first, I guess, to set this up? In order to install this, I'm going to create a virtual machine just to show you the install, because I've already done those install steps on actual hardware. So for today, I'll show you what you need to do. So if you come over to the Gluster docs site, you can find it, docscluster.org, and then it will take you here. So we can let's get rid of all that. Or you can go to the gluster.org main page and it'll take you there as well. You come down here to the install guide and then just drop down to install. And depending upon which distribution you're using, if it's Debian, you use that. This one is for Ubuntu, and then there's some down here for Red Hat and CentOS, which of course is gone. Also for Fedora, and then there's some if you're on Arch. What we're going to do is, if I come back over here and I do an apt search on GlusterFS, on Gluster, you'll notice there's a whole bunch of stuff that it shows me, but the client and the server are all 9.2. Well, I want to run on 10 because 10 has the higher performance. So those aren't in the repos yet. This is 2110, which is, as of time I'm doing this, the most current version of Ubuntu. And so, yeah, they have not updated yet to pick up the new versions of Gluster. So we're going to do the unthinkable and install a PPA. Why do I say that? So first thing they suggest we do is this, is to make sure that we have software properties common installed. Now, I'm going to bet that probably is already done, but I'll go ahead and paste in that command, and we need a sudo. That will not work without the sudo. And it says I've already got it installed. It's the latest version, so all's good. So the next thing I want to do here is to come down and look at the repo example. Now this is going to install 7. That's not what we want. So I'm just going to copy part of that. And we're going to do a sudo, and then I'll paste in that much of it. I want 10. So I'll put in the version number. Now, should I use something like latest or something like that? Maybe, but the way that their repos are set up is that when I come back in here, if there's a version 11 that comes out, then I would need to go and change this PPA to point to that, which I prefer to do, because sometimes the Gluster team releases things a little before they're ready sometimes, so I want to make sure that I've tested it first before I do that. So at this point, if I do an apt update, let's make sure we do the sudo, then it should download the packages that we want. You'll see that it did find my PPA and it did update there. So let's check what we got for GlusterFS now. And now we should have 10.1, which is the latest, and that's the one we want. So we'll go ahead. I'm going to install. Now this is going to be a server. If this were a client, I would just install that, and that's all I would need. But this is a server, so we're going to go ahead and do that. And it'll show you everything that it's going to be installing here, and some things that it's going to be removing as well. And we'll go ahead and let it do its thing. And I don't think that on this version of the install script that it actually will update the it will actually update and have the Gluster server come up. I don't think it does that, so we'll check that and make sure. I think it'll show that it's dead when I try to bring it up. And I am going to reboot after this because you can see that I have a new kernel here that's generating. So I will reboot this. Okay. And then we'll wait for it to come back up. Okay. Let's do a system control status. And as you remember, I don't know if you remember, but GlusterD is the service that is the main service that controls everything. So yeah, well, you can see it's dead. So what I need to do is to enable it first so that it will come up each time. And then I'll need to start it manually. Now, if some releases you may find that you don't need to do this, or some distros you may not need to do this. So we can go back up and look at the status again. This time it's up, it's running, it's all good. So I can do a sudo Gluster at this point. This is the main CLI for Gluster, and you can do a help, and there is peer, volume, snapshot, and global. So we can, let's do global help. So this is allowing me to get state on a file system or look at NFS Ganesha. Now NFS Ganesha is, so let me stop for a second. So Gluster supports clients on Linux. There, I believe, is also a client for BSD. However, there's no client for either Windows or Mac. So if you have a Windows and Mac environment that you want to bring in and use your Glusters as a share, you either have to run NFS or you have to run Samba. But the problem with NFS and Samba is that you're going to be pointing this at one of your servers, not at all of them. So if you have a problem in the background that causes that server to crash, that'll take your share down with it. So NFS Ganesha and CIFS, those both allow you to set up a round-robin pool so that you can, if the server's down, it'll try the next one. So you do get some redundancy there if you use things like NFS Ganesha instead of the NFS server. So, and also CIFS has within it the ability to set up the round robin in order for it to go through the servers. So yeah, so that's my suggestion. If you're running Mac OS or you're running Windows, that's how you can get to your Gluster server. I don't know if at some point they'll produce clients for that. It's possible, I guess, but so far they have not. So anyway, let's do peers are your servers. So this is how you would set up your trusted storage host. So yeah, without this you can't not set that up. Now I can do a peer status, and it's going to come back and say I don't have any peers. I can do a peer list, or a pool list, I should say. And it's going to show that I'm the only host connected here. Now, if I were to connect this to my main test cluster, the problem is that it's going to try to bring that server into the local pool here on this machine. That's not the way we want to do it. So normally you would go to the server that you want to attach this server to. So in my case, I would go over. I'm not going to do this because I don't have this machine in my NFS directory, but I would go here. Excuse me, my DNS. So I'll do a pool list here, and you can see what all is in the pool. So I have all of these servers are connected, and you'll notice they all have a unique UUID that identifies them. This is how you prevent people from spoofing, coming in and trying to be Tesla and trying to connect to this pool, because if they don't have that UUID, which is generated the first time you install the Gluster server and you bring it up, it'll generate a UUID for it. That will not change. The other thing is that all of this information is replicated between the peers. So I don't have to go to each one of those peers and add a server to the pool list. Once I've added a server, the other servers that are already in the pool, they'll be informed of this change through the protocol, and that will automatically update their configurations with the UUID as well. So in other words, it doesn't matter which one of the hosts I connect to as long as it's not the one I'm trying to add. So for example, I would do a peer probe on, this might work, 192.168.1.120. Now that's a DHCP address. That's probably not what I want to do, and yeah, it did it. So we'll do a pool list, and you'll see it right here. It's connected. So if I go back over to here, you'll notice that it picked up all of the servers here because, like I said, it replicates that information between the servers. So that's how it does that. Now, to remove that one from the peer, I don't want that in my pool, so I'm going to do a peer help, and the command is a peer detach, which is right here. So I can go and do a peer detach on 192.168.1.120, and it says the client, if that has mount points, they need to be remounted once you've done this. It doesn't, I haven't added any storage to it yet, but yeah, we can now do a pool list, and you'll see that it has taken it out of the list. Now, it may or may not have updated this yet, but yeah, it did. So it's gone from the list. So that's how you manage your trusted storage pools and get your servers added. The next thing we want to do is the volume command, and you'll notice that a couple of them here are, let's see, let's go all the way up to the top. So this one is add brick. This is how you expand the storage. This is how you initially create your volume, and you'll notice it has a huge amount of options here. This one is how you delete it, delete the volume. If you want to set up geo-replication, you can do that. And then you can get, this is where you store your there are a number of options that you can set in order to performance tune Gluster. And I can't recommend a set of options for you because it's dependent upon your workload. I mean, are you balancing for large files? Are you balancing for small files? There's information in the documentation on the process that you go through in order to set up what performance enhancements that would benefit you. And I can tell you with experience, a lot of those performance enhancements are very small improvements in performance. Now, if you get into larger and larger sizes for the pool, then a lot of those commands make a lot of sense. So that's just my experience with it. Small pools, I have never really seen there is a couple that kind of make a difference, but again, it depends on your workload, what you're trying to do. So I can't give you a set of recommendations, sorry, because I don't know what your workload is. But yeah, you'll see a bunch of them down here, like you can set up profiling, and this will actually start collecting data that will help you do that performance tuning. So yeah, you start this and then you run your workload that you're trying to tune for. It will show you internal statistics on what it's doing. Yeah, and then a rebalance operation is what you do after you add bricks to the pool, and that allows it to move files between all of the servers, including the ones you just added, so that your workload is balanced equally between them. And then if you need to replace a brick or remove a brick, you can do that here. So say a drive fails, you're replacing it with another brick, you can do that. And if you're removing a brick because you need to do something with it, like I'm waiting on it to be delivered, but I need to get it out of the pool so it stops using it. A start, and there's also a stop down here. So start and stop. This is after you've created the volume, you have to start it. So that puts it online and makes it available to your clients, and a stop will take it offline so that it is no longer available to the clients. And this gives you, the volume top gives you some performance statistics. Again, it's a little different than the profile. So this would be more like, okay, what's going on with the read and write operations and so forth. Whereas the other one is more comprehensive about what's really going on. So profile is more for performance tuning. Top is to find out kind of how it's performing, to give you some indication whether you have some issues going on. So I guess the first thing we need to do, now you can do these from scripts, so I'm going to just drop out of here, of course. And I'm going to do a create small on this, but to do that I need to make sure that I don't have any bricks on those commands. Okay, so I'm looking for Chandra, API, and Tesla on server, on my brick server, SRV, not SRV2. SRV2 is fine. I don't need to worry about that. It's because, as you can see, what I'm planning on doing here. So let's talk about this command. So this is the call to the CLI. I'm doing a volume create. This is the name of the mount point. So this is what I will be actually mounting for my clients. How many replicas of this do I want to create? Well, I'm going to do 3. So this is going to be, this is not a dispersed volume. This is a replica volume. And then transport, I just put it in as TCP. It defaults to that, but if you need IMDA, if you're on InfiniBand, then you would use IMDA for that. And then RDMA, I should say. And then you have Chandra. This is the name of the brick on Chandra. This is the XFS mount point, SRV, and then a directory under it. They always say to put this under here, and the reason for that is because if you want to, in some cases, you can create multiple bricks on the same volume. So I could have a brick and a brick 1 if I wanted to. And then this will be, again, this is just convention. I'm just using the same name as the mount point. So this is where my files would be actually stored, is under that directory. And then it's just a repeat. So the protocol is very similar to NFS, where you give it a host name : Now it doesn't have to be fully qualified, but just remember that if you are running a DNS version that you do not have a DNS search specified for, that could fail. And then finally at the end here, it's going to try to start it. So if this command is successful, it'll try to start it. So let's go ahead and try this. Okay, good. So it said I'm successful, and it will recreate the volume. So now if I go up to So I'll show you the re-info first, and it'll tell you that the type is a replicate. So I know this is a replicate volume. It gives me a volume ID, which again is unique to this particular one. And this is saying I have a 1x3 brick. So in other words, I'm going to be creating 3 copies of the file on this file system. So if I add a file, Chandra, API, and Tesla will all get it, and we can test that. So let me go back over here, and we'll just make a mount point. Now, clients don't have to be in the pool, only servers do. So let's see. I don't think I have anything mounted on this. Let's just make sure. I'll do a GlusterFS, and I want to mount API and rep1 SSD because that's the mount point I created, and we'll go ahead and we'll mount that on server. So let me, how about if I copy over? Let's just copy over those shell scripts. Oh. I think it's going to tell me that it's owned by root. Yeah. So this uses posix just like any normal file system. So as far as how this works with Linux, it's no different. So this time it worked. Now I can come back here and I can look at the raw brick. Well, I'll have to be sudo to do that. But you'll see that those files are there. And yeah, those are there in its entirety. Now, if I go over to, let me go back. To my client here, let's go over to Chandra. So you'll see the file is here as well. So if this was a dispersed volume, you might not see the exact, the exact same file, but we can check that it is 172. Yeah, 172 in length. And yeah, you do not write directly to your service brick. Let it go through your client. So can a server have a client? Yes, a server can have a client, and you can turn right around, mount us on Chandra as another mount point, and you can do it. Now, should you do that? It's fine. I mean, it'll work properly, but in my case, we'll just execute this from the client as if we were whatever we're doing here. So that is a replicated brick. Now, so the next step is we want to destroy this, right? So I'm going to do, let's go ahead and destroy this one. So the first thing, take it offline. So I can do it, let's do it, wait, I didn't show you this. Now I can give it a full name, and this will only show you the status for the brick in place. So you'll notice that a couple of things here. So it's telling me the name of the volume, and then it gives me this table. So the three entries here are the bricks that are entered. If there are other machines in the pool, they become involved in the self-heal daemon. And yeah, so if they're needed, they can be involved with keeping track of what's going on rep1 SSD, basically what that's doing. There's no active volume tasks. So I could do, and then we'll do a start. So it says you don't need to do this because it's not a distributed volume. So yeah, I mean, it knows that it has copies of it already done. So, okay. let's do the next step. So what I want to do is actually create that distributed volume, right? So I have a script set up for that. It's not that one, it's that one. So in this case, I don't need to stop it. So I can just run this command right now, and then I'm going to add bricks from, well, actually, that's incorrect. I want to add those from this one up here. So, yeah, I want to do this one because these are already there. So I want to do this one. I'm going to add a brick from Cassini, Hubble, and Lowell to do that. So the first thing we need to make sure of, let's get out of here, is I'm going to use my friend Ansible. And I happen to have a host set up to do this. So we'll do an M shell, and we'll do an ls minus lr slash srv, and we'll do a minus b, which is the becomes. So yeah, I think we're good. Hubble has brick. Cassini has brick. And you have to have this directory already created. So you'll need to do that when you set up your servers. Yeah, it looks like we're good to go there. So I'm going to go ahead and do, let's see, do I have to run? Yeah, I can just do this. So and it should come back and say success. So let's look at the info for this now. Okay, so now you'll see it has a 2x3. So that means that two of the servers, it's created two groups of servers. One group is so each group is distributed, and they're in groups of 3. So Chandra, Oppie, and Tesla are in one group, and Cassini, Hubble, and Lowell are in another group. So it's going to replicate between Cassini, Hubble, and Lowell. It's going to distribute between the group Cassini, Hubble, and Lowell and the group Chandra, Oppie, and Tesla. So to start that, we have to do, let's do a volume status on it first. Oops. Okay, so yeah, you'll see here. Now there's no indication of which one is which, right? You don't know which one is that. So let's do. So let's see if on the info, if I have any other, nope, no other things I can list. But I can we don't need to start it. This will take a second to start because it's got to inform all of the members of the cluster. and then we can look, and it's already completed. But there wasn't a lot there, so you can see that it did run on one of the servers to move stuff. So, yep, and it's done. The rebalance operation, it depends on how much data you have, but it doesn't take a whole lot of time. So now I shouldn't. Well, come on. Oh, goodness. There we go. So I should not have anything on Curie. I'm sorry. Well, it did. It put out one of them. It moved one of them over here. So during the operation, it did move one of the files over to this one. So yeah, so this file should, I wonder if it moved. Yeah, okay, so it split the files. It put one here and it put the run file over there. So that's, you can see how it's working. So this file will exist on all three of the group that I just added. So that's pretty much how it works. So let's go ahead and go back in here. Oh, one other thing we need to know about. Let me see, did I have an ls on it back here? No. So right now, my file system has a total of 1.8 terabytes. So that's using 6 terabytes, and I'm only getting 2 back. Yeah, that's not a very good. This is not a very good use of my storage. So yeah, I'm using up 6 terabyte of storage, but I'm only getting 2 back. Now, if I want that level of redundancy, that's fine, but this seems ridiculous. So the first thing I want to do is I'm going to U-mount my client drive here. Yeah, that's fine. And then I'm gonna stop it over here. Okay, and then I'm gonna destroy it. Okay, so now if I do a volume status, it's gone. Rep 3 is there, drep is still there, but there's nothing else, and I can do a volume info. It's gone. Now, one problem that you're going to have, though, is you'll notice that it left rep 1 and my file is still here. Now, that will not go away. So I need to clear these out manually. The problem is if I attempt to put another brick called rep, if I try to install rep 1 SSD again, it's going to say, hey, that's already here and you can't do that. So I need to clear that out so that I can do that. So let's go back over here to my blue eyes, and what we'll do is there we are. Gotta remember what I called my scripts. So in this case, it's going to clear out all of them. So we'll go ahead and run that. And unfortunately, this clean is going to also remove brick. So I'll need to create that back. I had an Ansible command here. There it is. I'll just change this. Because if you look here now, this should be gone. Yeah, my brick is gone, and so now I'll have a problem. It won't create it. It won't create anything new either. So we'll go ahead and do that. And now my brick is back. So I'm all good to go. Now the next step. So this time I'll go into Gluster. And you'll see my test volume is now a disperse type. And this is a little bit different in that it's showing I have 3 bricks, and it's a 1 by, so there's no distribution here. This is just 3 different servers, 2 of which are storing data and 1 of which is providing redundancy. So that's what that is telling you. And that is automatically calculated. I didn't have to add that. I can attempt to force it into 1, but it probably would give me a message that is not optimal. So the next thing I need to do is do a start on test volume. And now we're up. So I should be able to go back over, not there. I don't want to go there. I want to go here. Here, we'll do it from Chandra this time. It doesn't matter which one you mount. Yeah, it does not matter. Okay, so let's take a look and see if we have it mounted. And you'll notice that I've only got 3 bricks, but I'm getting the same amount that I got on the last one. I'm getting 2 terabytes back. So at a cost of 1 terabyte, I have all the storage I need here. So I can, let's copy over those as well. Let's do that again. Oh, I'm going to have to do it as sudo. Okay. And you'll see them there. Let's go look and see what it actually stored. Oops. It is storing a block of 512, which it always does. So those files have everything in it, but there is a erasure code that's written with it, and it's going to write out a block at a time. So yeah, that is how I understand this works. So yep. You'll also find that the speed difference between this and replicated volumes is going to be a lot faster because it's not writing as much. Replicated volumes cannot complete their IOs until all 3 drives have completed the IOs, for example, in a 3-way replica. So the next thing we're going to do here is we're going to do kind of the same thing we did before. See if this will do it. Okay, so it created this as you just dropped the dispersed out of it. But this did create a distributed dispersed, this is a 2 by, and then 2 by plus 1. So I have redundancy within, but not across. So yeah, so my storage has doubled because the dispersed areas have added together, but the distributed nature allows me to have that happen. So now out of 6, I'm getting about 4 terabyte. So yeah, still losing quite a bit of space, but I am gaining redundancy here as well as I am gaining more space than I could get with the distributed replica. So that is how you do that. And that's as far as I'm going to go today. Yeah, you can definitely there's definitely a lot of experimenting that you can do with this to see how well does one particular volume perform versus another. I can tell you that from my experience, and I'll show you some benchmarks at the end of this video today, but I will show you that as you add complexity to your Gluster drive, your performance will drop in some areas and increase in others. Now, in my case, once I get up into and as I scale up my load, I'm going to cap the network, and that's as far as I can go. Remember, the design for Gluster is to have the servers on a 10 gigabit network. I don't have that with my ARM, so I cannot do that. So if you tell me, well, you put this on a 1 gig network, I'll just say, yeah, no kidding, that's all I can do. However, the network that those machines are tied into is a 10 gig. So yeah, and so there will be some aggregation there, but probably not a lot. So that's all I had for today. I hope you enjoyed this video. If you did, please like and subscribe. Hope to see you all again real soon, and bye for now.